Welcome to myprojectbazaar.com. Now we are going to discuss about the paper title of Predictive Handling of Asynchronous Concept Drifts in Distributed Environments. This is the abstract of our discussing paper. In the distributed computing environment, peers collaboratively learn to classify concepts of interest from each other. When external changes happen and the concept drifts, the peers should adapt to avoid increase in misclassification errors. The problem of adaptation becomes more difficult when the changes are asynchronous. This problem is solved by developing an ensemble approach which combines the reactive adaptation via the drift detection and proactive handling of upcoming changes via early warning and adaptation across the peers. It shows that asynchronous concept drifts also is better and faster than current state-of-the-art approaches. Now we can start examining the data flow diagram of this project. At the first stage, we take the training dataset of weather, which is used to convert it into a matrix for further classification, and then multiple classifiers make use of this matrix, which leads to the Bayes classifier model, which utilizes the Bayesian algorithm. The output of these Bayesian algorithms will be given to the fusion classifier, which utilizes the C-means clustering algorithm as a fusion model. The values generated by both the classifier models will be given to the ensemble classifiers, which takes the input of testing dataset to produce the final classifications of class vector. Now I will show you the demo of this project, starting from its home page, which displays the title of this paper, and then now we are going to select the weather dataset, which considers as a testing dataset as our input. Now the selected datasets parts will be generated in here, and now these are the dataset contents which is going to be inserted into the database. Now we have to convert these dataset into the matrix conversion like this. We just classified the matrix into T0 to T11. Finally, these matrix classifications is going to be applied using the C-means homogeneous clustering algorithm. Now I will get the homogeneous values for 3 clustering values like this for 1, and for second clusters, this is for second clusters, and this is for third clustering homogeneous values. Now these, with the help of these homogeneous values, I will cluster the entire dataset values for each of its record. Now we have to start calculating the heterogeneous clustering with the help of the C-means algorithm. Now the generated homogeneous values will get displayed in here. To start applying its heterogeneous values for it is clustering among the clusters. We just group these homogeneous values into cluster 1 and cluster 2 and cluster 3. Now next step is to apply these values with the help of this Bayesian classifier, which make use of the naive Bayes algorithm. Before that, we have to evaluate its parameters of probability of A by B, and then probability of A, and then probability of B. Now these parameter values should be applied in this Bayesian algorithm's formula to get the final result. Now with the help of these values, now we're gonna generate a decision tree. For this decision tree algorithm, we have to calculate the confidence matrix for each attributes and its corresponding classes, and the number of clusters that contains in a 1, 2 and 3, and finally we can calculate its information gain for each matrix. We get it here like this, and we have to evaluate its entropy values, and among these entropy values we will generate a gain for 3 types of clusters. With the evaluated gain values, now we are going to construct a tree based construction. Now we just classified the entire data set under this cluster 1, cluster 2 and then cluster 3 with its corresponding classification values. At last we displayed the final result using this random classifier for further prediction. Now the result will get displayed in for each attributes with just clusters, and its values will also be just gets grouped, and then finally it just clusters the entire data set for this classifications algorithm. At last we are going to evaluate its efficiency. Now the efficiency calculations will contains the correctly classified instances in percentages, that is 97%. Incorrectly classified instances is 3%, and these are the some static values which is evaluated in the space paper. Thank you for watching this video.